Hey everyone, so you're interested in learning about the different properties or laws of logarithms. Well, in this video, I'm going to show you the three most commonly used properties of logarithms. This is the second video in a three-part series where I'm explaining the logarithm concept. If you're new to logarithms and you're interested in knowing about the basics of what logarithms are, then consider clicking on the link up here. If you have a good basic understanding and you know the different properties of logarithms, but you want to see some real-life applications of logarithms, then click on this other link up here to see those applications. Otherwise, if you want to see the properties, then keep watching these videos. My name is Peter, grab a calculator and let's get started. Let's start the second part of the tutorial by looking at the properties of logarithms. So the objective is to understand how we can use those properties to simplify and evaluate expression. Whenever you simplify an expression, you're changing it from something that's really complicated to something that's easy to work with. Now, in this example here, we have a really complicated logarithmic expression, and we want to see how we can simplify it. So let's start off by looking at the properties. On this slide, I'm showing you the three different properties, but later on we're going to look at each property with some examples. The first one is called the product property. The reason why it's called product is because we are multiplying two numbers here, m times n. If you're multiplying them, it's the same as taking the logarithm base b of m plus log base b of n. The second property is called quotient property, where you have log base b and then you have here m divided by n. So this is the quotient, and if you are dividing two numbers m divided by n, then it's the same as subtracting the logarithms. And then finally you have power property. So you have m to the power of n is going to be equal to n, which was the exponent, times the log base b of m. Now let's take a look at some examples of each property. So product property is the first property that we're going to look at, and it says the logarithm of base b of m times n is equal to log base b of m plus log base b of n. So here we have a question where we have log base 4 of 32 plus log base 4 of 2. The bases must be the same for you to use this property. So what this means is we are going to multiply, we're going to write log base 4 and then multiply 32 times 2. 32 times 2 is simply 64. So now we have this log base 4 of 64. We can simplify this logarithm. So when you simplify it, we're going to write log base 4 64 is equal to y. In the last video, in the first part of the tutorial, I explained that if you want to look for the log, you're looking for the exponent. So which exponent gives us 64? Which exponent of 4 gives us 64? And that exponent is simply 3. So the simplified form of this log is just a 3. Another example that we can look at is log base 3 of w plus log base 3 of y squared. So in this case here, we actually have variables, we have expressions. So let's go ahead and use the product property, which says that we need to multiply the two expressions. So we're going to multiply w times y squared because the bases of the two logarithms are the same. So when you multiply w and y squared, you just end up with w times y squared because the two terms are unlike terms, and this is the simplified expression. The quotient property is the next property we're going to look at. So if you have log base b, m divided by n is the same as just subtracting the two logs. So the first example, we have log base 4 of 36 minus log base 4 of 9. So what we're going to do is we're going to divide 36 divided by 9. That's going to be the first thing we're going to do. So this quotient can be simplified to just log base 4 of 4. So now we want to simplify further this logarithm. Log base 4 of 4 equals to y. And I'm going to rewrite this logarithm in the exponential form. So I want to figure out what is the exponent of 4 that gives me a 4. And the exponent of 4 that gives me a 4 is just a 1. So the simplified form of this difference is just a 1. The second example is log base 6 of 7k minus log base 6 of y to the power of 4. So if you're subtracting the two logs, you divide again. So we're going to just write log base 6 and then 7k in the numerator and y to the power of 4 in the denominator. And that's the simplified form. Power property is the third property we're going to look at, and it says the log base b m to the power of n is equal to n, which was the exponent, times log base b of m. So I've got two math problems here that we're going to go through together. In the first problem, we have a 3, a coefficient, times log base 2 of 4 minus log base 2 of 8. So the first thing that we want to do is we want to rewrite the first log using the power property, and that's going to be log base 2, 4 to the power of 3. All you do is take the coefficient and turn it into an exponent, minus log base 2 of 8. That one stays the same. And then so what I'll do next is, since we are subtracting the two logarithms and they have the same base, I can divide the two numbers here. 4 cubed can be written as 64 and then divide by 8. And then we can simplify that simple quotient. So we're going to have log base 2 of 8. 64 divided by 8 is 8. So now we want to simplify this logarithm. So if I want to simplify that, I can rewrite it in the exponential form. Exponential form looks like this. 8 is equal to base 2 raised to the power of y. So I want to figure out what is the exponent here that gives me an 8, and that exponent is 3. In the second math problem, I have 4 log base 5 of k plus 2 log base 5 of 3. So I have exponents and I also have the product property. So I'm going to be combining two properties here. So I'll start off by rewriting the first log as log base 5 k to the power of 4. I just take the coefficient and make it an exponent. And I'm going to do the same thing with the second logarithm. I'm going to write log base 5 of 3, and in the exponent I'm going to put the number 2, which was the coefficient. The next step, I recognize that since I'm adding the logs, I need to multiply k to the 4th power times 3 squared. So I'm going to simply write k to the power of 4 times, and then 3 squared can be written as 9. And then I'm going to rewrite that as log base 5, 9k to the power of 4. Always put the coefficient in front of the variable. Do you remember this problem from the beginning of the video? It looked really long and complicated. Well, we're going to use the properties that we've just reviewed to try to simplify this long, complicated logarithm expression. So the first thing I notice is the first logarithm and the second one are separated by a minus sign. So I'm going to use the quotient property, which says log base 3, x plus 1 goes in the numerator, and then 3x squared minus 3x minus 6 goes in the denominator. The last logarithm is separated by a plus sign. That means I need to multiply x minus 2 times x plus 1, and that just goes in the numerator. So now we have this quotient of a product in the numerator and a quadratic expression in the denominator. So this is a hint, a really huge hint in mathematics. We probably want to factor the denominator. So the first thing I'm going to do is I'm going to factor out a common multiple, which is 3. So I'm going to write the numerator. It's going to be the same, x plus 1 and x minus 2. But in the denominator, if you factor out the 3, you're going to end up with 3 parentheses, x squared minus x minus 2, close parentheses. So now this expression inside the parentheses here is a little bit easier to factor. Now, if you don't know how to factor quadratic expressions, I suggest you watch the video that is linked up here that explains how to factor quadratic expressions. So when you factor this quadratic expression, you're going to end up with x plus 1 times x minus 2 in the numerator, and in the denominator you're still going to have that 3 that you factored from the very first step, but in the inside the parentheses you're going to have x plus 1 and x minus 2. So now this expression that is in the denominator, it's exactly the same as the product that is up here. So all we're going to do is start to cancel this the like terms. All the parentheses have the same terms, so they cancel each other, and in the numerator you remain with a 1. So our logarithm expression is going to be log base 3 1 over 3. This expression here can be simplified by rewriting it in the exponential form, which is 1/3 is equal to base 3 raised to the power of y. So I need to figure out what is the exponent of y that gives me a fraction. So y has to be a negative number. So y is equal to -1. That means our logarithm expression simplifies to -1. Let's analyze some logarithm statements here and label them as true or false. The first one is log base 2 of 4 plus log base 2 of 8 equals to 5. So if I want to know if this statement is true or false, I'm going to analyze each of them. I'm going to rewrite the first log in exponential form, get an answer, and then rewrite the second log in an exponential form and then add them together and see if I get 5. So the first one, I have 4 equals to 2 to the power of x. So I need to figure out what is the exponent of 2 that gives me a 4. And the answer, has to be 2. Let's do the same thing with the second log. I have 8 equals to 2 to the power of x. What is the exponent of x? The exponent of 2 that gives me 8. And that exponent has to be 3. If you add 2 plus 3, you're gonna get 5. So this statement here is true. And let's go to the second statement. We have log base 3 of 3 halves is equal to a half log base 3 of 3. So this statement here, what happened was a half was factored out from this fraction here. Now that is false. You cannot factor out a number from this term here and make it a coefficient. The only way you're gonna get a coefficient here is if the half was the exponent of 3. So that second statement is false. The third statement, we have log of x inside parentheses squared and log x squared. So the difference here is you're squaring the logarithm, and the second expression is you're only squaring the x term. So these two expressions are not the same. So this is false. And the final statement, log base 4 of 7 minus log base 4 of 3 is equal to log base 4 of 4. So in this case, they just subtracted 7 minus 3 to get 4. Now this is false. If you want to simplify a difference of logs, you need to divide 7 divided by 3. So the final statement is not true.
Here's a quick pro tip when it comes to simplifying complex expressions that involve logarithms. Ensure that the bases of those logarithms are the same before you can use the product property or the quotient property. If the bases are different, then the product and the quotient property are not going to work. And that's the pro tip.
After doing so many examples, let's go ahead and take a look at some independent exercises for you to try on your own. These exercises are meant to test how much you understood from today's video. All of the answers from these independent exercises can be found down in the description box below. Good luck!